Alright, we got another infinite boy here today. We got the integral from 0 to 1 of the square root of x plus the square root of x plus the square root of x plus the square root, and it keeps going on and on forever. So remember, the way we tackle these kinds of infinite integrals, whatever, is we let this whole big infinite thing equal to a variable. Typically, we want to say like just y. So like y equals square root x plus square root x plus square root x plus, and then it just keeps going on forever. But then the thing we notice is that because it goes on forever, if you just remove one of these terms, it's still just y in our case. So we could say that y equals, this is all y, but then we still have the square root of x plus. So here it'd be y equals the square root of x plus y. From this point, we could square both sides, so we get y squared equals x plus y. And that's also y squared minus y equals x. At this point, what we could do is complete the square. So our b value here, b is equal to -1. So our b over 2 is going to be -1/2. And our b over 2 squared is going to equal 1/4. So what we could do is we could add 1/4 to both sides. And at this point, this left-hand side is a perfect square. And that's going to be y minus 1/2 all squared. And on the left, or on the right side, we still have that x plus 1/4. And so from here, we could square root both sides now. So we get y minus 1/2 equals the square root of x plus 1/4. And adding 1/2 to both sides, we get y equals the square root of x plus 1/4. All of that plus 1/2. And now we have a value for y. So we could just replace that value for y into our integral here. So the same integral is equal to the integral from 0 to 1 of the square root of x plus 1/4 all plus 1/2 dx. So with this now, we just, it's easy integrating here. It's basically use substitution, but it's one we could do in our head. This is going to equal x plus 1/4 all to the power of 3 over 2, all multiplied by 2/3. And then over here, we're integrating 1/2. That's just going to be x over 2. And don't forget, this is a definite integral, so it's all going to be evaluated from 0 to 1. Evaluating this at 1, we're going to get 2/3 times the quantity. So this will be 1 plus 1/4, so basically 5 over 4ths to the power of 3 over 2. And plugging in 1 here, we just get 1/2. So now we subtract, plugging in 0. Plugging in 0 to here, it will be almost the same thing. We will have 2/3. Just instead, this time it will be times 1/4 to the power of 3 over 2. And then it will be plus 0 over 2, which is just plus 0, so we can leave that as it is. And because this is just one term, we could get rid of these parentheses, and it's just minus this term right here. Now, what we want to do is we're going to simplify all this. So these 3 over 2 powers. So what we want to do, because there's no calculators allowed really in integration B, we can't just plug this in. So what I did to actually solve this was I changed the 1/2 powers to square roots, and then instead of multiplying together 5 times 5 times 5, I just wrote that as 5 times 5 times 5 over 4 times 4 times 4 under the square root. So we're going to do that with both these things. So that's our first term done. We still have this plus 1/2 here. That's just an outlier kind of thing. And then minus 2/3 times 1/4 to the 3 over 2. So we're going to do the same thing there. So 2/3 times the square root of 1 times 1 times 1 over 4 times 4 times 4. From here, let's just move this 1/2 up to the front so we don't have to worry about it really. And so over here on this first term, so square root, we need 2 of the same term under the square root, and then we'll just have to pull that one term out to the outside. So we have 2 5s here. And so we can pull that out. So we'll still have this 2/3 as that constant out front. But because we have these 2 5s, we can square root that, and that just turns to a 5 in the numerator out front. And then we'll have left over a root 5. In terms of the denominator, what we can notice is that 4s are actually squares in themselves. 4 times 4 times 4 is the same as 2 squared times 2 squared times 2 squared. So we'll have 2 squared twice. So in the denominator, we'll have 2 times 2 times 2. So we just dealt with this term. We dealt with that 1/2 earlier. That's why I put it over here. Now we can work with this term. -2/3 times the square root of 1 times 1 times 1 over 4 times 4 times 4. And this is actually really nice because the square root of 1 is just 1. And 4 times 4 times 4 under a square root, we just dealt with that over here. We know that's going to be 2 times 2 times 2. Another nice thing, so notice that these terms and these terms are all basically one term because they're all multiplied together. So we could cancel a 2 here and here, as well as a 2 here and here. So closer to our final answer, we'll have 1/2 plus, now let's start simplifying things. 5 root 5 is all we have in the numerator for this first term. In the denominator, we have 3 times 2 times 2, which is the same as 3 times 4 or 12. So this term will be 5 root 5 over 12. And if we go over here to this term, we'll have 1 over 3 times 2 times 2, which is the same as 1 over 12. Simplifying this a little bit more now, 1/2 and minus 1/12. So let's get a common denominator of 1/12. So 1/2 is the same as 6 over 12. So 6 over 12 minus 1 over 12 is going to equal 5 over 12. And don't forget we have this plus 5 root 5 over 12. And so now we can actually factor out 5 over 12. So our final answer will be 5 over 12 times the quantity 1 plus root 5. And that was a lot of simplifying work because we don't have the ability to use calculators in integration bee. But this is our final answer. 5 over 12 times the quantity 1 plus root 5.